So yesterday, we gotten through the front page. And then we might have done, for this class, let's see here. Yeah, this class, we did a couple of these examples on the second page, correct?
Yeah.
So we're going to keep going here and do some more practice problems with these, and then I'll give you some more time to work on the homework. So let's look at letter C. Letter C has three terms, right? We've got the 64, we've got the X, and we've got the Y. Each of those needs to be raised to the 3/2 power. So when I write this out, I'm going to say that we have so the 64 to the 3/2 power, 64 to the 3/2 power, X to the 6th to the 3/2 power, and Y to the 1/3. Y to the 1/3 to the 3/2 power. Does everybody understand that basic step, that every piece inside the parenthesis gets its own exponent of the 3/2 power? We're good with that? Because again, that's the basis for a lot of these problems. It's not technically the distributive property, but it's very similar to the distributive property. It looks very similar. So now, let's go ahead and apply each of these. Some of them are super easy. 1/3 times 3/2. Is everybody good with the 3's canceling there? 3 on the top, 3 on the bottom. This becomes just Y to the 1/2 power. X's, I can simplify the 2 and the 6, or you could do 6 times 3 is 18 divided by 2. Just however you want to multiply 6 times 3/2. We should end up with X to the 9th power. And then the number over here, you have two options. Do not multiply 64 by 3/2 because the 64 is not an exponent. It's 64 raised to the 3/2 power. So either now simplify that using square roots, right? It's a 2 on the bottom, that would be a square root, or rewrite 64 as something to a power so that you can multiply those powers. Either way is fine. So again, the two ways, one way would be to write this as the square root of 64 to the 3rd power. That would be fine. Another way to do this would be to say that 64 is 2 times 2, 2, 4, 8, 16, 32, 64. It's 6 2's. Does that make sense to everybody? So if we have 6 2's, I could write this as 2 to the 6th power times 3/2. Does that make sense to everybody? Wait, we already did that, didn't we? The X was 6, X to the 6th power. So this is going to be the same thing. 6 times 3/2 is going to be 9. You can do 2 divided by 6 is 3. And then 3 times 3 is 9. So 2 to the 9th power, X to the 9th power, Y to the 1/2 power. Now, that 2 to the 9th power is starting to get into the realm of that's too big to multiply out. I think it ends up being okay. 2, 4, 8, 16, 32, 64, 128, 256, 512. So it's not too bad. You could multiply it out. If it was like 2 to the 11th power, we're getting into the thousands. You just leave it as an exponent. Does that make sense? If you ever need to do it though, just 2 times 2 times 2 times 2 times 2. Just multiply it 9 times. I'd say, I'm going to go ahead and say you can leave it like that on this one. Does anyone have questions on that problem? Yes.
How would you solve it?
This one? So this one, I would take the square root of 64. Do you know what that is? Yeah, it's 8. So we'd have 8 to the 3rd power. And if you multiply that 8 times 8 times 8, we get that same 512 that we got if we did 2 to the 9th power. Does that make sense? Both of those are equivalent. I will accept both. Now we need to do some of the other types. So let's do some multiplication ones. So here, actually, let's practice one that we just did. I want you guys to do, if you haven't already in your homework, everybody try try 28. 28 is super similar to what we just did. Everybody try 28. Get the homework up here for the recording also. Oops, nope, that's not the one we are doing yet. So again, everybody try 28 here. Give you 3 minutes. We did a warm up. Any questions so far? Okay. Sorry, if you want to get that to me, you can do that. We did 1, 2, and 3.
Because 10 times 2 is 20 divided by 5.
Yeah, let's sign up.
It's 2. It's 4. How do you do this?
You could do 2 times -1 divided by 4. That would be fine. Or you can cancel out the 2 and the 4. You can do the either of those work. But yeah, what you're doing is multiplying 2 by -1.
No, he did it different. Why is that? Is it? So it would be 2. What's square root of 2? Two.
8, 4. 4.
They have to be 5.
8 times 4 is 13.
It is, but there's multiple ways to get the same answer. So you guys could be arguing over the same thing.
Wait, what did you say? 8 times 4? 8 times 4?
Yeah, you can do 8 times 4.
Oh, it is 5.
That should be fine. All right, everybody, let's try 28 here. See how we did. Then we need to keep going. So first things first, let's get that 2/5 distributed to everything. So Faith, walk us through like what ends up getting that 2/5 exponent. Just that first step. Okay.
Times x times 5.
Yep.
Y 1/2 times 3.
Perfect. Is everybody good with that first step? We're just making sure that exponent makes it into all 3 pieces. Okay. You're one person. It's okay. I saw a couple head nods. Again, I can't help you. Walking around, it looks like you're doing good work. But again, the more response you give me, and it can be no. If I ask, are you okay? You can say no, and I can go over it. Just the more response you guys give me, the more I can figure out where I can help you. So let's go ahead and keep going then if we're all right. At least Jason's all right. Hopefully the rest of you are all right too. So Abby, what would you do next here? You can pick of those three which one you want to do. So if you've done one of them, you have maybe haven't finished it, you can just walk us through one of them.
The y, you cancel the twos and the 1/5.
Perfect. The y becomes y to the 1/5 power. Then Priscilla, we got a 32 and an x. Which of those do you want to tackle? Okay, so what did you do with the 32?
I finished one.
That's okay.
I think so, what I did is I found the numbers, I like two and two. I got the, but I haven't figured out what the number is.
Okay, so you're right. It's a bunch of twos. You haven't figured out how many twos there are?
I did it like 5.
That's right. There's 5 twos. So we've got 2 to the 5th power. And then is everybody good with this, that I'm multiplying that by the 2/5? Now that I have an exponent, I can multiply those. I couldn't multiply 32 by 2/5 because it wasn't an exponent. So now, how does that simplify? I'll let anybody that wants to do that one. You can volunteer. You can make it 5/1. Careful, not 1/2. 2/1. There we go. So this ends up being really just 2 squared. 2 squared. And again, if you did it another way and you got 4, you're fine. There are so many ways to do these problems as long as you're using the rules. So whichever way you want to do it, it works just fine. You should end up with 4 at the end. How to get that 5? So it's the factor tree. It's breaking up that 32 and saying it's either 2 times 16 or 4 times 8. Break it all the way apart. You should get 5 twos. All right, now the last piece that we need to do is the x. Bao, can you talk us through how we simplify the x? Okay. Uh-huh. Yep. That's perfect. Is everybody good there? 10 times 2 is 20. 20 divided by 5 is 4. So our final answer here, 2 squared is 4. X to the 4th, y to the 1/5. The 32, remember, was the 2 to the 5th. You worked us through that one. That was you. That's right. So that the 32 became 2 to the 5th power. 5 and 2 to the 5th canceled. We ended up with just 2 squared is 4. Yes.
I'm not seeing it, but why does the 2 squared become 4x?
It becomes 4, but then the x's was up here, 10 times 2 to the 5th. The 5 and the 10 cancel out, just a 2. 2 times 2 is 4 there. That's just coming down. I'm putting all the pieces together. We did the 32, we did the x, we did the y, and we got 3 different pieces all multiplied together.
The answer is 4x.
Y to the 1/5. Yes. That's the whole thing all together. Okay, let's go back to the notes. Let's do some multiplication ones. Everybody's full attention here. These should be easy as long as you keep your rules separate. Everybody, again, your full attention here. What you do to the exponents is different from what you do to coefficients. So right here, let's actually skip letter D for a moment. Let's look at letter E, everyone. If I multiply these together, is everybody good with the exponents getting added? This is x to the 3/4 plus 3/8, right? Exponents get added together. Here's where people make mistakes though. What we do to the exponents is not what we do to the coefficients. This is literally just 4 times 2. The numbers out in front get multiplied. The exponents get added. 2 different rules. Don't mix them up. So here, 4 times 2 makes 8. The x is, okay, I need a common denominator. We're still doing that. Looks like 4 is not quite big enough, though. We need 8. So I'm going to go ahead and make this one, let's use a different color here. I'm going to multiply this one top and bottom by 2 times 2 times 2. So really, this is going to be x to the 6 over 8 plus 3 over 8. And then we add like normal. My final answer is 8x. Remember that once you have the common denominator, that's the denominator still, but you add the tops. 6 plus 3 is 9. I multiplied the top and bottom of this one by 2 so that the denominators would match. And so 3 times 2 is 6. Yep, sorry. It didn't quite look the same. So if we go back then real fast, we can knock out D super quick. The 3 on D stays out in the front. It's like 3 times 1. X to the 2/3 plus 1/6. Get a common denominator, which means top and bottom here by 2. So then I have 3x to the 4/6 plus 1/6. And yeah, some of you are going even faster than I am. 4 plus 1 is 5/6. Does that make sense to everybody? Adding basic fractions. So the idea is whenever I'm looking at these fractions, if I don't have the bases the same, I'm going to have to multiply one of them by something so that they match. So I had a 3 and a 6. I can make the 3 into a 6 by multiplying it by 2. Does that make sense? They're both 6s. But I multiplied that 3 by 2. I have to multiply its top by 2 also. And so it had a 2 on the top.
Oh, I thought that was 1. That's
No, yeah, again, this, I try to make it clear. I don't know what it is about this program, but it doesn't like some of those curves when I'm making small numbers. If you ever see a number like that, and you're not sure what it is, you can ask.
How do you know if it's 2?
So you're deciding whatever this number needs to be multiplied by to match this one. So I multiply 3 by what to make 6?
Oh,
I multiply by 2. All right, division. Look at your rules. Division means subtraction for exponents. So this one, literally the same thing, but subtract. 4/5 minus 3/10. So then multiply the 5 by 2 to make 10. X to the 8 over 10, right? Top and bottom by 2. Minus 3/10. X to the 5/10. Wait a second, that one simplifies. Haven't seen too many of those yet. 5 over 10 would reduce to 1 over 2. X to the 1/2. All right, I want you guys to all try one of these. Let's have you guys do number. Everybody try 32. 32 on the homework. And Addie, I'll give you a pass. And if you think you can, you can take one of those steps as well. This is 77. I think I already did the 130. We'll talk about that. I would use the fact. Exponent, top minus bottom. Y.
I think that's wrong. Look at that.
Yeah, you're good. Yeah, try 32. 4 and 3 is 12. 4 minus 4 plus 3. Yeah, perfect. Excellent. Alex. Yeah, good inside out. All right, so check your answer. Check your answer if I didn't check it for you already. All right, and the last little piece of this lesson are these guys where we kind of put it all together. We've got division, we've got multiplication, we've got exponents, all together in one problem. Nothing new, just can we do it all at once?
No.
I think you can. I think you can do it. So look at letter H. Now, I'm going to give you, again, like I've been doing, a couple ways to do these. So for letter H here, you could write the 27 and 64 as something to a power. So if you do that, you could change this, make it 3 to the third power. 3 to the third power, x to the 12th power. Do you have a pass? Okay, so they're making everybody first period go get a pass before they come to class if you're late. So you can leave your stuff there. Do you have a mask? Okay. X to the 12th times 1, or let's see, let's do it like this. Still the 1/3, I haven't distributed it yet. 64. Take that 64 and say, well, that's 4 to the third power or 2 to the 6th. You can do it either way. I'm going to do 4 to the third. Y to the third. And then what I'm going to do is distribute in this 1/3 to everything. So because every single term now has an exponent. Is everybody, again, this is one way. I rewrote my numbers as something to a power. So 27 is 3 times 3 times 3. 64 is 4 times 4 times 4. Then when I multiply each of these, I now have an exponent to multiply everything by. All my exponents get multiplied by 1/3. 3 times 1/3 cancels out. I'm left with just the 3 on the bottom. 12 times 1/3, 12 divided by 3. 12 divided by 3 is 4. On the bottom here, 3 times 1/3 cancels out. I'm left with just 4. 3 times 1/3 cancels out. I'm left with just y. That would be one way to do that problem. The other way you could do this, the other way you could do this is to say, okay, 27 to the 1/3, it's the third root of 27, right? The third root of 27. On the bottom, the third root of 64. That would end up being 3 and 4, same thing we got before. Okay, that would be another way of doing it without the exponents, instead using radicals. Okay, I'm not going to do I, but I'm going to give you a little hint. Does everybody see that 32 divided by 2 is 16? I would write this one as 16x to the 4th over y to the 8th raised to the 3/2. Does that make sense to everybody? That would simplify that one a little bit for you. Then you could do it the rest of the way. Let's instead do letter J, and then we'll call this set of notes good. Letter J, 48 and 27. Does 3, I think 3 goes into both of those.
Yeah.
So let's simplify it a little bit. Clean it up. 48 divided by 3 is 16. So you'd have 16 x to the 10th. 27 divided by 3 is 9. Not x, y to the 4th. All raised to the 3/2 power. So that means again, 3/2 power goes for the 16, to the x, to the 9, and to the y. So all of those are going to have a 3/2 power. So right now that looks like this. Spread it out a little bit. 16, x to the 10th, 9, y to the 4th. All of those get that 3/2 power. 3/2 times 3/2, 3/2, 3/2. So again, a couple ways to simplify those numbers. The numbers you could go ahead and write as something to a power, right? Something to a power. Or for both of those, you could go ahead and just write them as square roots. So like this one, the 16, you could write as the square root of 16 cubed. And the 9, you could do the square root of 9 cubed. Class, what's the square root of 16? 4. And then you can do 4 times 4 times 4. So this guy would be 64. 4 times 4 times 4 is 64. Square root of 9. The square root of 9 is 3. 3 times 3 times 3 is 27. Okay, so I'm hearing some mumblings. Let's make sure we're following what's going on here. So I took the 16 and the 9. Both of them got raised to the 3/2 power. The 2 on the bottom. The 2 on the bottom is a square root, right? Square root of 16, square root of 9. Both of them raised to the 3rd power. Does that make sense?
Yeah.
Okay. So now I have to deal with the variables. So I just took the square root of those 2 and then cubed them. The variables, 10 times 3 would be 30, divided by 2. 30 divided by 2 is 15. So we have x to the 15th power. On the bottom, 4 times 3 is 12, divided by 2 is 6. There is my answer, 64 x to the 15th, 27 y to the 6th. Now, I want you guys to try, I want you to try 30, no, let's do 38. 38 is harder than 36. So try 38. If you guys need help with 34, we can go over that one too in just a moment. But right now I want everybody to try 38. Yeah, that one, the 2 doesn't. But everybody, you can save yourself some time. Does 2 go into 128? Yeah, simplify that. That would make it easier for you if you do that first. Simplify the 2 and the 128 first.
There's 64.
Okay. No, okay. Right here.
Why did you get that? So good.
So y,
No.
15,
Yeah, we did it.
1 times 4. 15 divided by 3 is 5. 5 times 6 is 10. That should be y system. And then the 64 gets its
Why
own.
do you, everyone has different
Yes. Because right now the 64 you didn't bring.
Oh,
Don't you know? No, you do two,
Okay.
that is 64,
You
64
just
here
asked
and a
me to go.
one.
He's finishing up his problem.
No, it's
Uh,
not.
after
No,
either T
Four is
or
not
Alani
64.
comes back.
Yeah, it sure is. No, it's not.
Okay, so, yeah, you didn't actually do the Cooper. To do this Cooper 64 and square it, no question.
No, I don't.
One second, let me answer her question and then I'll come back. Okay, so she's just not done yet. So yours, you need to simplify. This is gonna be easier than what she's doing, but you are missing your Y. Your Y disappeared. So put the Y and then make sure the 64 gets its own 2/3. So what she was talking about is the 2 and 128, you can simplify those. And that would save you a lot of time because then you only have to do one number to the 2/3 power instead of 2. Does that make sense? But then yes, do 6 times 2 over 3, 5 times 2 over 3, those will simplify. And then just have to do, after you simplify this, whatever that is. to the 2/3 power. So go ahead and finish that. I'll put the answer up here in just a minute for you guys to check. So we've got a little bit of a lag. After, right now, I think Alani's out.
What's 15 times 2, 20, 30?
Right, because you don't multiply.
15
Why
times
don't you
2.
pause for a minute? I'll go over that. Clarabelle, why don't you go right now? And then don't go, because I want to show you that, because you're doing exactly what I'm worried
What
about.
does
We'll
it
do.
mean by whatever you
64 is on exponent, so it doesn't get multiplied by the 2/3. It's 64 raised to the 2/3. That's different. So let me show everybody. Okay, let's work this out, everybody. Again, if you finished, check your work. If you got stuck, let's see if we can unstick you. The first thing, when I see 128 and 2, I would simplify that at the very beginning. 1, 2 goes into 128 64 times. Then I can rewrite this, the top x to the 6th times 2/3. On the bottom, here's the problem, and I'm catching some of you doing this. Do not multiply the 64 by 2/3. The 64 is not an exponent, so it doesn't get multiplied by that exponent of 2/3. It gets raised to the 2/3 power. And then the y, it has an exponent 15, that gets multiplied by 2/3. Does that make sense to everybody? Maybe? Oh, there's paper towels right there. So now, and Ali, if you want to go right now, that would be fine. Again, he wanted to check this, so he can go after you. It'll work out. So here, everybody's good. The x and the y you can multiply the exponents. 6 times 2/3. Is everybody good here? 6 times 2/3. That's going to be 12 divided by 3. 12 divided by 3 would be 4, so x to the 4th power. So if you just do 6 times 2, that's one way of doing it. You could also do 3 divides into 6 2 times. You get it same way, same answer. The bottom here, y, 15 times 2/3. 15 times 2 is 30, divided by 3 is 10. That would be one way to do it. But what I need everybody to see is you don't multiply the 64 times 2/3. You either do the cube root of 64 and square that. So the cube root of 64 would be 4. 4 squared would be 16. That's what would go here. Or you write that 64 as something to a power. You could do 2 to the 6th power to the 2/3. That way, when you multiply 6 times 2/3, you get 4. 6 times 2 would be 12. 12 divided by 3 would be 4. And if you get 2 to the 4th power, that is 16. 2 times 2 times 2 times 2. Yes.
Is that what
So let's go back to the notes. Which one are you looking at? So on H, I changed these to have an exponent. It was 3 to the 3rd power and 4 to the 3rd power. And so I multiplied the exponents together. 3 times 1/3, 3 times 1/3. Does that make sense? And that's what I did here. I can write that 64 as 2 to the 6th power and do 6 times 2/3. Does that make sense? So as long as you get an exponent, then you can multiply. So as soon as one of them comes back, you can go. Okay. Yes.
So for the 64 over 2,
The 64 to the 2/3, that's this right here. I wrote the 64 as 2 to the 6th power. Or you write the 64 inside a cube root for the 3 on the bottom of that exponent. I showed you 2 ways to deal with that 64. Does that make sense? Does one of those 2 ways make sense to you? I know that's the problem with me, like doing it multiple ways and only in a small amount of space. Do you want me to rewrite it real fast? Would that help? Just like the 64 by itself. Okay, so real quick, I'm dealing with the 64 to the 2/3. Do you want to see it using cube roots or do you want to see it using exponents only? So I took the 3 on the bottom and said that that means this is the cube root of 64 squared. Does that make sense?
Yeah.
Then I actually took the cube root of 64. You break it apart, use a factor tree, you get 4 squared. And 4 squared makes 16. Does that make sense? All right.